All right. Now, I'm trying not to sponsor this for all folks. Sorry in advance. But for those of you who don't know, I think it's like 2 or 3 of you. My name is Miss Nelson. Nice to see you. I'm trying not to throw your name in a second remember, okay? But there's 10 questions here. We're going to go through probably all 10 because I think we're going to have time, okay? So, what Mr. Earl told me to do yesterday is he kind of went through a couple and then you do like the 1 minute and kind of test it out. We're going to do the same kind of system, okay? So we're going to start with number 1 right here. It says, what 2 numbers should be placed in the blanks below? So the difference between consecutive numbers is the same. Now, what's happening here is it gives you a starting point of 17. Oops. And it gives you an ending point of 41. And you have 2 gaps you need to fill in the blanks for right here, okay? So what you're going to want to do is find the difference between 41 and 17, okay? Now this is where your calculator can come in super handy because you do this in your head, right? But if you have a calculator and you type it in, it speeds it up for you much faster. So grab a calculator, no worries, if you need one, you can grab one out of the back, awesome. Or you can steal your neighbor's, probably not the best idea. But 41 minus 17, we get 24. And then if you split a 24 up into 2 separate parts, because you have 2 different numbers, it should be a 12. So that means from 17 to this first blank should be plus 12. And then from the second blank to the third blank should be plus 12. And then from the third blank to the 41 should be plus 12. Okay? So we go 17 plus 12. Who got a 29? Yes? Nope. 25? What am I doing wrong? Hold on, guys. If I type this wrong into my calculator. 29, yeah, because that would be too much. That would give us 32. Hold on, Richard. Okay, wait, hold on. Sorry, guys. Erase this. Yeah. It's because the difference, so you gotta count 1 less. So to get this to be a 25, this is gonna be a difference of 8. And then 25 plus 8 is gonna be a 33. Sorry, I put this in the wrong spot. And then plus another 8. Yeah. So the reason why, thank you, Richard, for making my mistake. The reason why is because you have to count 17 to 41 is like your difference between the 2 numbers, but you're adding it 3 times. So I was counting as I was adding it twice. So really, you still have 41 minus 17 is 24, but you're going to go 24 divided by 3. So you add 8 every time, which is why that's your question, Katie?
Yeah.
Okay, Richard, thank you. So your answer is letter C, 2533.
The number letter C.
Yeah. It's a good one. I thought today was Tuesday, guys, so sorry. Any questions on number 1? We're good? Okay, all right. Number 2, here we go. Which of the following statements describes the total number of dots in the first n rows of the triangular arrangement? Now, with this, are we, just 1 second. Are we all aware by what it means of first n rows? So n just means the number that you're looking at in the current row, okay? So you could theoretically like continue this number on multiple times, okay? Now, this triangular arrangement, this just means in your first row, we've got 1 dot, right? Second row, we've got 3. Third row, we've got 5. Fourth row, we have 7. And the fifth row, we have 9 dots. So what I would probably do is just write this out, because one thing I notice, guys, when people do ACT questions, they try to go really fast, which is good because you're like going for a minute a problem, right? But you don't want to miss like a tiny thing like counting a dot, so if it helps, like you can write it down, okay? Now, these ones are kind of the longer questions because it doesn't give you per se like a straightforward way to answer it. It gives you a lot of options that could be correct. You kind of have to do process elimination instead, okay? So say you start with A. It says this total number is always equal to 25 regardless of the number of rows. So what it's saying when it says the total number of dots in the first n rows, if I add up all these dots, am I going to get a 25 every single time? So if I were to add on another row of dots, right, each time it's going to like the next odd number, so if I were to add on 11, the number's not going to consistently stay at 25. Are we okay with that first part? So that means we're like A is out, okay? Can't use A, it's off. Now it says B, it says this total is equal to twice the number of rows. So that means if we add up the total dots right here, okay, so if I add up 1 plus 3 plus 5 plus 7 plus 9, this would be a 4 plus 5 is 9 plus a 7 is 16 plus another 9 would be 25, right? So if I'm saying that the total number of dots is equal to twice the number of rows, thumbs up if you think that one's true, thumbs down if you think it's false. Sideways if you're not sure. It's okay not to know. Okay, this one's going to be false, folks, and here's why. It says total is equal to twice the number of rows. If I do twice the number of rows, that's going to be 5 times 2, right? That's how many I have currently. That would give me a 10. But that is not a 25, right? So B is out. We okay with that? Okay. Is anyone not liking this question as much as the first one? That's okay. The logic ones are kind of tricky, okay? All right, now part C, it says this total is equal to 5 times the number of rows. So I have 5 times the number of rows. Currently I have 5, right? 5 rows. So if I go, this would be like 5 times 5, which that does equal 25, right? So right now that one checks out, but we haven't checked the other 2 options. So we're gonna like not cross that one out, leave it on the table, but not for sure guarantee there's an answer yet, okay? Then part D says this total is equal to the square of the number of rows. So this would mean if we square something, this is like a number times itself. So if I take 5 squared, that's like 5 times 5. That also equals a 25, which checks out, okay? So far that one's not off the table yet either. It just is an option still, okay? And then E says there's no consistent relationship between this total and the number of rows. So this one says basically we have no pattern, okay? Now, these ones are always kind of, who hates the questions where it's like all of the above or none of the above? That's kind of what this option is saying, okay? And those ones are like, you pick that one if you're like, yeah, I think this is what it is, but don't maybe pick that one as your first option until you've like kind of vetted everything thoroughly, okay? So if we come back to these 2, let's pretend that there were only 4 rows. Let's say we eliminate this 5th row. Pretend it's not there. So we just add up the first 4 rows. If I say 1 plus 3 plus 5 plus 7, that would equal let's see, 4 plus 5, 16, thank you. So this would be a 16, right? So if I go 5 times the number of rows, if I go 5 times 20, so this is from part C, okay, excuse me, 5 times 4, that'll give me a 20, right? But is a 20 equal to a 16? Nope. So that means C just broke down, right? C just broke down, doesn't work anymore. Because now if I go 5 times the number of rows, 5 times 4 rows, it doesn't give me that same answer I should get. I should get, for my total, I should get a 16. So say I do the square, right? If I go 4 squared, that gives me a 16, right? So D checks out again, right? That one gives me the right answer one more time. So if you're like, okay, it's really looking like D, say you weren't sure and you wanted to check it all the way through. If I go 3 squared, okay, I'm gonna erase my arrow right here. If I had 3 rows and I did 3 squared, that gives me a 9, right? How many dots is the top 3 rows? 9, right? So that one checks out. If I went 2 rows, that would be 2 squared. How many dots is the top 2 rows? 4. And if I just did 1 dot, it's like a lone dot right here. Okay, that would be 1 squared. And how many dots is the one bottom by itself? Just 1. So D, folks, is our winner. Okay, it works every single time, no matter how many rows you have. All right. What do you think about number 2? Thumbs up, you could do it. Sideways, like you understand. If you're like, that one's kind of rough. Thumb down is like totally lost. Okay. All right, guys. Any questions about it? No. Okay. All right. Let's do the next one. Now, one thing, guys, keep in mind, when you do the ACT, right, you want to do all the questions that like, oh yeah, I can totally do this in like under a minute. And then you do the questions, you're like, I could figure this out, but it could take some work, right? It could take some time. for me, if I were taking ACT, I would probably classify that question we just did under that. I can figure it out, but it would take some time. So if it was one you like initially skipped and came back to, that's okay. Okay, that's not a problem at all. Okay, number 3. Which of the following statements is not true? This one's kind of like the last one. Which of the following statements is not true about the arithmetic sequence 17, 12, 7, 2? Okay, so I'm gonna write this out so it's just a little bit neater. I feel like it's a little bit hard to see squished in there. Okay. So, first one says the 5th term is -3. Okay. Well, to find out what the 5th term is, you have to figure out what the pattern is between the other 3. So, question here is, what number are we subtracting as we do this problem? 5. You got it. So, if I subtract 5, right? Do I get a -3? Yes, right? That does work out. So that one is true. Okay. Now, here's the thing. If that one's true, this is where, what's the key word that kind of flips the contrast of the statement around? It says not true, right? So the first one's right, but you don't want to click that one. You want to pick that one because that's asking which one does not work. So it says the sum of the first 5 terms is 35. So if we add up all of these, if I go 17 plus 12 plus 7 plus 2 plus a -3, 17 plus 12 is 29, plus another 9 is 38, minus 3 would be 35. Is that what it said? Yes. So B checks out, right? So far A and B are both right. So C now says the 8th term is -18, okay? The 8th term is -18. I feel like I don't want to figure out all the 8th terms. Well, we can skip that one and come back to it, okay? So if you look at part D, it says the common difference of consecutive terms is -5. What that means, guys, is what you told me the first. What number is it subtracting by every time? It's subtracting by -5. Every time you move a number, it subtracts 5 off. So D is correct. Okay. And then it says the common ratio of consecutive terms is -5. Now, question, guys, do we know what common ratio means? Thumbs up, yes, thumbs down, no. And I feel like, no, I'm not mad. That's okay. Like, we're gonna review. This is actually stuff from like way back in like 8th or 9th grade. Like, it was a long time ago. Okay. So what a common ratio means is if you have a number sequence that divides. Okay, let me give you an example. 1, 2, 4, 8, 16. Or I should say multiplies. What number are we multiplying by in this instance right here? A 2, you got it. So that is a ratio. This is called a geometric sequence. You multiply. But a arithmetic sequence means you add. Now, are we multiplying it all in these numbers? No, right? They're all subtracting. So E is the one that breaks down, right? E is going to be your answer. That's the one that's not true. Now, if you're like, well, we didn't check C, you're going to go back and check C, right? You just have to do 3 more numbers. So if we subtract 5 again, that would be -8. Subtract 5 again, -13. Subtract 5 again, -18. And so that is going to be your answer. How come about number 3, guys? Pretty good? Okay. Any questions? Okay.
So common ratio is always multiplying.
Yeah. So common difference goes with arithmetic sequences. You add and subtract, and a ratio would mean you multiply it by. Is that okay? Good question. Any other questions, guys? Good? Is this good pace? Okay. All right. Ready for number 4? So this is a little, maybe like the last one we're going to do together, and we'll start doing the 1-minute part. Okay? No stress. It will be relatively painless. Okay. What is the slope-intercept form of 8x minus y minus 6 equals 0? Thumbs up if you remember what the slope-intercept form is, folks. Okay, someone's yes, someone's no. No worries. If you don't remember, that's okay. It looks like this. I think once I put it up, you're going to be like, oh yeah, I remember this. Y equals mx plus b. Is that familiar? Yeah, right on. Okay, so the slope right here, where's my other color? Here we go. M is your slope, right? B is your y-intercept. That's why it's called slope-intercept form. So if I take 8x minus y minus 6 equals 0, I want to get y by itself and then 8x and the number on the other side. Now, here's the thing, guys. The ACT, people really write questions for a job, like they do this on purpose. So if you notice, see how everything's on the left side? Your initial reaction lots of times is move to 8x and the 6. But what would be the fastest way to get the y by itself? Add the y. Yep, you got it. If you add the y over, right? This is 8x minus 6 equals y. which would give you H as your answer, okay? Now, here's the thing. Is it wrong if you do it the other way? No. Okay, this is why I love math. There's so many ways to do it, you get the right answer every time. And that's why I said drive some people nuts. But the thing to keep in mind, okay, is that on the ACT, right, you want to try and not change the way your brain thinks, but help it think through that process and not like second guess yourself, because that's what slows you down. So when you like go back and like, did I do it right? Right, you go back and check. So if you're like, oh yeah, I can go that way, give it a shot. If you're like, no, I want to stick with how I do it, that's fine. Okay. All right, let's do number 5, folks. I'm going to time you for a minute. You ready? Now, if you don't get done in a minute, that's okay. This is just a practice round, okay? You ready? Set, go, okay? See how far you can get on number 5 in a minute. If you're like, I don't remember how to do parallel lines, that's okay. Give it your best guess. No worries, about that. It's so much. All right, you got 10 more seconds, guys. And stop. All right, who got B as their answer? Awesome. Okay, now if you didn't get the B, folks, that's okay. Let's talk about why B is the answer. But one real quick testing tip with this, okay? Should you ever leave a multiple choice question blank? No, that's like the ultimate sin of testing, okay? If the answer is like a multiple choice question, that means one of them is the right answer, right? So when in doubt, Amy right now, just guess, okay? So parallel lines. The first thing you have to know about parallel lines is they have to have the same slope, right? And if you're like, well, how do I find their slope? Well, you go back to a slope-intercept form, right? We're going to take 7x plus 9y equals 6, and we're going to solve it for y. So if I subtract 7x over, you get 9y equals negative 7x plus 6. Divide by 9, you get y equals negative 7x plus 6. And when you have one fraction, you can split it up into 2 parts, just like that. So you can put the 9 under the 7x and 9 under the 6. And the slope then is the coefficient of x, that negative 7 over 9. So any line that's parallel to this is going to have a negative 7 over 9 as the slope. That means it goes down 7 and 9 to the right. All right, about number 5. I think that was that, right? Yeah. Any questions on that? Or Jackson?
What do you use common knowledge for this? Like, I looked at y, I looked at x, and I was like, oh, one of the answers is 7 over 9. Negative, if it's parallel, would be the opposite sign.
Yeah, you could do that. You could do that. You just want to make sure you don't miss a negative sign, because to do perpendicular lines, it's the inverse and opposite sign. So it'd be like 9 over 7 positive. So I just watch out for that. But yeah, you could totally do that. Good question. Is that okay? Any other questions, folks? Okay. Number 6. Ready for another minute one? Anyone already started? I'm not mad if you did. That's okay. All right, number 6. Are you ready? Minute beginning now. Ready to go. Okay. See how far you can get in a minute, folks. No, not yet. That's okay. Just guess.
Nice.
'Hey, go up by the locker room. Find all the distance runners that are down here and go by the locker room.
10 seconds, folks. I'm going to shut the door. Alright, and time, folks, or past it, 5 seconds. Okay, I actually don't know what the answers on this one. Who got J? Oh, not true. Not true. J is not a letter, but it's the one it says on here. I guess, yeah, I think it means D.
Oh,
That is funny, it doesn't match up.
J is D on the other
Oh,
Yeah.
good to know. I wonder why they don't match up. Okay, well, good to know. I'm gonna do the same thing we talked about on number 5, or number 4, sorry. I'm gonna add 11y over. So you get 14x plus 16 equals 11y. And then if we divide by 11, that divides this by 11 and this by 11. So the slope is the coefficient. So D, also known as J. How you have to keep the J axle. Okay. All right. Anybody want this? Jen? Yeah. I don't do best those or calling this. Just speed up. 30 seconds, 7 minutes. Okay, we can do that. Number 7. Oh, this is a fun one. Word problems. Our most favorite things. Okay, so I'll give you a minute. People want to read. So, starting now, ready to go. Read through it and see how far you can get in a minute. Alright, yeah, I think 15 seconds works. And time, I think. Okay. Alright. Who said F? We're gonna go with letters up here. Who said F? Who said G? Who said H? Who said J? I don't know why I skipped by. And who said K? Yeah. Alright, you're correct, folks. It is G. Because that's the slope of your line, right? So right here where it says T equals 10p plus 5, that means 10 minutes per page plus the 5 minutes from the starting time. So every time he does another problem, it adds on 10 minutes to his included minutes. Don't figure out word problems? Now, here's the thing. Who's normally like word problems are not their most favorite thing ever? That's okay, guys. But I feel like this one looks scarier than it was. Don't worry. See, you got this. Yes, I got some copies yourself. Okay? Alright, now we're not going to do a 1 minute on this one because who hasn't done sine, cosine, tangent for a long time? No worries, that's okay. So, we're going to talk about how you review this. And even if you had math last try, guys, if you had like 3B, the second half of math 3, this is actually like a super specific concept that I don't think we really get into in our time. So this is what's called a trig identity. Do you see this funky equation right here? That's what's called a trigonometric identity. There are a lot of them, okay? Now, based on this problem, they don't expect you to have it memorized because they put it in the equation for you. So you just have to learn how to translate from the numbers to the variables, okay? So it says, what is sine of pi over 12, given that pi over 12 equals pi over 3 minus pi over 4, and that sine of this symbol is called alpha. It's a Greek letter, okay? And then this symbol right here is called beta. It's also a Greek letter. So given that sine of alpha minus beta is equal to sine of alpha times cosine of beta minus cosine of alpha times sine of beta, okay? Do you want to feel like doing friendly green for shampoo bottle? Okay. Sorry, I got that. I was on your right and you're like, what is going on? So, here's the thing. Let's break this down one piece at a time, okay? You totally can do this problem. They're just trying to scare you, okay? First thing, they want to know what is sine of pi over 12, right? So we're like, what do you want to know? Well, we want to know what this thing is equal to. Sine of pi over 12, okay? Now, what it tells us is that pi over 12 is pi over 3 minus pi over 4, okay? Now, if you're like, well, that is some really useless information. Think about, like, why would they give you that? What does does that give you that helps you with the next function, the next formula in the problem? Okay, so take a look at this, sine of pi over 3 minus pi over 12, and then take a look at this equation. All right, if I look at this, I have this alpha minus beta, right? So what really happens here is that you have sine, and then this alpha, okay, minus beta can be the equivalent of pi over 3 and pi over 4. Okay. Now, the Greek letters are just because all the other Greek guys got first dibs on trigonometry. They're all the ones that discovered it first. They got to name everything, okay? So it's not like our regular variables like x and y. The alpha and beta act just like an x and y. So what you're going to do is anywhere you have an alpha in this equation, you're going to put a pi over 3. Anywhere you have a beta in this equation, you're going to put a pi over 4. Thumbs up or good to there. Any questions? Go right in.
How do you know it's A and B? Like, where
Yeah,
does it
how
say
did you-
that?
Oh, good question. So what you're doing essentially is matching up. So like, how do I know like it's alpha and it's beta, or how do I know
How do
that
you
pi over
know
3 is
How do
alpha?
you know pi over 3 is alpha?
Oh, good question. So what it would be is you're comparing. I'm trying to think of what I can relate it back to. Here we go. Think back to what we were doing before. So y equals mx plus b, right? If I had I think it was like negative 7x over 9 plus 6 over 9, right? You matched each item up to the previous part of the formula. So right here, the y's are equivalent, right? The equal signs are equivalent. The x's are equivalent. The plus signs are equivalent. So all that's left by default is that this has to be m, because everything else around it has been claimed. And this has to be b, because everything around it has been claimed. Does that answer your question? So in the same format, because you have sine and sine, and a minus and a minus, this by default has to be pi over 3, and this by default has to be pi over 4. Does that answer your question?
Yeah.
Sorry, I'm not explaining it very clearly. Really good question. So it's because you're matching up each piece. So you start with the parts that look similar, then everything else that hasn't been matched up to a piece in the formula is left over and put into the remaining parts. Good question. Really good question. Any other questions up there, guys? No? Okay, so now we do this funky formula, okay? So it says sine of alpha minus, or excuse me, not yet, minus cosine of beta. Now minus cosine of alpha times sine of beta, okay? And now becomes a plug and chug problem, okay? Everywhere you have an alpha symbol, you're gonna put in pi over 3. Everywhere you have a beta symbol, you're gonna put in pi over 4. So this problem is now gonna look like this, okay? You're gonna have sine of pi over 3 in parentheses, and then you're gonna have cosine of beta, which is pi over 4 in parentheses. And you're going to go minus cosine of alpha, which is pi over 3, times sine of beta, which is pi over 4. Do I have a copy for yet? Right. Shake your hand out. Okay. Now if you're like, well, that's great, almost, I'm like, well, that's not even close to the answer. Well, we haven't used all the information to do this yet, okay? What's the last piece of information that threw out there that we haven't looked at yet, guys? The table, right? The table's just been hanging out. We haven't looked at the table at all. So see how this little thing, note, you may use the following table of values. Now, it says sine of pi over 3 is, so think of this as kind of like a matrix. Or not a matrix, but like a chart. So the sine column is this left one. The cosine column is this right one. And then it gives you pi over 6, which we don't have any values for. We have pi over 4 and we have pi over 3. So if I want sine of pi over 3 right here, my sine column and my pi over 3 column is the square root of 3 over 2. So I'm going to put right here square root of 3 over 2, just like that. So that whole sine of pi over 3 is equal to the square root of 3 over 2. Any questions there? And that's coming from that table of values, okay? Now, cosine of pi over 4. So I got my cosine column, pi over 4, that's this one, square root of 2 over 2. So I'm going to multiply the square root of 2 over 2. Then I go to cosine of pi over 3. So cosine of pi over 3, right column, bottom row, 1/2 in parentheses. And then sine of pi over 4, the last but not least, the left column on the second row, square root of 2 over 2. Okay. All right. Thumbs up, thumbs down to there. Can we match all those up into the equivalent forms? Okay. Now, before you go type all this in your calculator, folks, here you're into a small problem. What kind of answers do we have to deal with? They're all square roots, right? Or they're all fractions. So decimals are not a lot of help here, okay? Which they probably did on purpose. So what we're gonna do, we're like, we got this, we can multiply. So when we multiply fractions, you multiply the top to the top, the two numerators, and the bottom to the bottom, the two denominators. So square root of 3 times square root of 2, I'm gonna do this up here. This would be a square root of 6 over a 4, okay? Square root of 3 times square root of 2, you multiply the two numbers inside the square root, and then square root of 2 times 2, that would be a 4. Everybody wait for Mr. Burrell. Look at this fun problem we're doing. This is his favorite one, I bet.
This is my favorite one.
I called it. All right. Okay. And then right here, 1 times the square root of 2 is going to be the square root of 2. Okay. And then 2 times the 2 is a 4. All right, folks, where do you see this fraction? Is this one of our answers?
Yes.
Yes, right? Kind of in disguise, but it's K. And the reason if you're like, well, how can it be the same? It's because when you add fractions, the denominator doesn't change. It stays the same number. So multiplying fractions, the denominator can change, but adding fractions, it does not change. So two fractions can be combined into one. Then you have square root of 6 minus square root of 2 over 4. And that's your answer, folks. And then, smiley face, drop the mic, because that was a long problem. All right, guys. Okay. Now, take a breath. That was kind of a marathon of a problem. Thumbs up, you understand that. You're like, yep, I follow that. Like, it was brutal, but I follow that. And if you're like, not really, that's okay. No stress. Do you have any questions about it? Okay. Yeah. Now, you know, guys, give me thumbs up that question take you longer than a minute. Okay, now, here's the thing. This is probably, the ACT gets harder as it goes, so this is probably not one of like the first 30 questions. Probably like the second 30, okay? They get a little trickier as they go. So, say you're down to like 5 minutes left on the ACT and this is a question that you got. What would you do?
Yes.
Yeah, that's okay, that's no problem guessing, right? So like, I'd probably bubble it in, and then I'd probably give it a shot, right? I'd probably try and say, can I figure this out still, right? Because say you guess it right, no problem, right? Say you guess it wrong, and you figure it out right before the 5 minutes, and you go and change your bubble, right? And then you can switch it up. All right, say it in there, go for it. That was your question. Okay, you're not going
If you're
for
going to take ACT again, or right now, like now, I guess, after you know all this stuff, would you get like 100% on it if you had more than?
You know, I'd probably miss a negative sign, and I probably wouldn't understand exactly go down this. I don't know. Like, I mean, I know how to do all the math, but negative signs are my nemesis. So. But I would hope I would get a good score. I don't know. I do ACT questions like this, but I haven't taken all this for a long time. Yeah. Now, one thing too, guys, with this, this table, so in Math 3, okay, some of you know my class, who's in this tray, but like, who's taking Math this tray? Who's got 3B this tray? Okay, so if you haven't taken Math 3B yet, and you use trigonometry, you're gonna learn about something called the unit circle. That's where this table comes from, okay? So if you like have time to do some spare research, or if you want to.
Anna Krieger, if you're in the building, please come to the office.
Okay, so if you've got a little bit of time and you want to look it up, you can look up Mr. Burrell's videos on YouTube, or you can come talk to any of the math teachers. But these numbers come from what's called the unit circle, which is basically like a picture formula. It's a circle with all of these angles and sides measured out. If you have more time, then I'll actually do it. Okay, but But when ACT gives you these numbers in the problem, you may or may not need it. Okay. All right, any other questions on this one? No. Okay, now don't be scared, folks. Okay, don't be scared. You got this. It looks like a mess, mainly because I just read it really large. Okay. All right. Ready for number 9? Back to algebra. Not that this wasn't algebra, but it was a little more trigonometry than algebra. Okay. All right, number 9, folks. Let's give you another minute. You ready? Beginning now. Ready, set, go. Okay. See how far you can get in a minute. Okay, you got 10 seconds. All right, and time. Okay, who said F? Who said G? Who said H? Who said J? And who said K? Okay, the answer is, I'm gonna check K. So let's review it, folks. No stress. Now, this answer, if you did G or H or J, you probably are on the right track with the algebra, but there's probably a distribute all the way. So let me show you what this means, okay? The question's saying if f of x equals x squared minus 2, then f of x plus h equals what? Anytime you have something different inside these parentheses after the f, so instead of f of x, it says f of x plus h. What that means is everywhere you have an x, you're instead going to put an x plus h. So if your equation is x squared minus 2, you're going to put in x plus h squared minus 2. Okay? So if you put in the plus h, like you're on the right track, but it's kind of tricky where you stick it in. Thumbs up or good to there. You okay with that? Okay, now here's the next thing usually gets people. This squared means you have 2x plus h's. Okay? So this is when you distribute it, you're going to have x times x first. Okay? And then you're going to have it as an x squared, and then x times h times x. And then you're going to have h times h, which is h squared. That's a 2. Okay. Now, one thing that kind of throws people off, guys, these two are actually like terms, even though they don't look the same. X times h and h times x. Because, tell me this, folks, are we all okay that 4 times 2 is the same as 2 times 4? That's the same thing. So x times h is the same as h times x. So right here, we can really write this. So I'm going to skip down here. X squared plus 2xh plus h squared. Now, do you see how that's j? That's not the right answer. The reason why is, what did I forget? So minus 2. Yep. They throw that on there at the end. So really, you got to have x squared plus 2xh plus h squared minus 2. And then, voila, k is your answer. Sometimes we can do that one now. It's just kind of wordy. Maybe wordy is not the word, but lots of variables. Okay. All right, ready for the last one? Some more trigonometry fun stuff. So we're not going to do a minute on some folks, just because I know we did a lot of algebra first try, and we haven't done trig yet. So if you look at this and you're like, what is going on? Who's seen a graph like this before? Okay, about half of us. If you never have, no stress. This is what a trigonometric graph looks like. So if you graph sine of x or cosine of x or tangent of x, well, tangent won't look like this. But this is what a graph will look like of a sine or cosine wave. Okay, so let's go through and read this. It says a trigonometric function with this equation, a times sine of bx plus c, where a, b, and c are real numbers. That just means that they are, they can be like positive, negative numbers, or like integers. Okay. or decimals. It says it can be graphed in the standard xy coordinate plane below. The period of this function, f of x, is the smallest positive number p, such that f of x plus p equals f for every real number x. One of the following, which means one of these answers right here, is the period of this function. Which one is it? Okay. All right, now thumbs up if you understood any of that. Sideways is solid, thumbs down is none. No worries, folks. Okay. Now, can I translate this into like normal English? Then we'll kind of talk through it. What the period of a function is, okay, right here, according to this definition, is it means if you're going to get back to the same number. Okay, so trig functions are what are called periodic functions. They repeat themselves. Okay, so you see how this is a very similar pattern. It goes up to 2, down to 2, up to 2, down to 2. This back and forth. Okay, so this f of x plus p equals f of x is it wants to know when do you get back to the same number. Okay, so what I want you to do, if you'll draw a dot right here on your y-intercept, okay, I want you to just mark that because then you know that your y-intercept's at 2. Okay, now if you trace this line down, 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 up, 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 and you stop where it hits 2 again, that is one wave of your graph. So the period of your graph, it is the distance from here to here. Okay? It's how long that one wave is. That's what the question's saying. Thumbs over that part, makes sense. Okay, okay. Okay, now here's how fast it is. You find where this is, and you go down to your x-axis, and you see where it says pi right here? That's your answer. Because that's the distance, right? If this is 0 to pi, that's how long it takes to do one wave. So you're like, what on earth?
Wait.
We're gonna go back through that? Or is that just like an excellent?
Wait, how does that mean that that's the answer?
So what it's saying right here, this f of x plus p equals f of x, this means when do you get the next y value that's equal? Because f of x is like y, right? So at 0, you have a y value of 2, and at pi, right? So if you had, think of it like an xy chart. If you had 0 as an x value and pi as an x value, on each one of those you have a 2. And in between, you've got all those other numbers, right? But it wants to know when do you get back to a 2. When that happens is a pi.
Okay.
That's what that whole question is saying, okay? Sound good?
Yeah. So why so hard?
Because here's the thing, I've never talked to anyone that's written an ACT question meeting, but I really think they try and kind of, I don't know if like, they're just trying to make it, see if you can get the gist of what's going on. Is that fair? Okay. Alright guys, how are we going up today? Functions, pretty good, in between, sort of ish. Okay, do we have any other questions we want to go over? Are we good? Okay. Alright, sorry we went over by 5 minutes, so thanks for coming. You're wonderful. If you have any questions, feel free to ask.